Hello Internet, I got this 3070 from EVGA in for repair. This is a nightmare repair. And the reason for that is because it came back for warranty. And the reason for that is, look at all that beauty. So there's rust everywhere, you can see it here. It was so bad that I had to replace the HDMI port. The pad was eaten, so I had to replace the pad. There's a whole lot more on the back, especially around the controller, multi-phase controller. So let's switch over to a microscope. I'll show you all that glory. Like literally every resistor and capacitor, everything is rusted. And I tried to reflow this whole area. I replaced a couple of resistors, maybe either on the front or the back. Some of them are looking better, some of them are looking worse. And so when I got it unboxed, it was completely dead, kind of like it is now. But I was, for whatever reason, it was getting me a whole voltage, full voltage everywhere, momentarily, and I would touch this area here. I would just kind of run my finger over this area here at the front, left top, right there. So I'm just gonna go over and it starts to boot, but right now it doesn't. Yeah, right now it doesn't do anything. It's just pulling like 0.8 of an amp. And basically what's going on here is we're missing the core, basically. So there's no core. So we have 5, we have 1.8, but we're missing the core. And how do you go about finding a problem like that? Well, there are no board views that will match. I don't think that there's a board view that, last time I tried to find one, that would match the layout of this board exactly, but there were some that were reasonably matched. So we're gonna have to go off of that. So board view is a big help here. But ultimately, we're trying to figure out what is it that we're missing, or what is it that keeps going on and off. So the probably the go-to method here is poke around the logical AND gates and see if they're missing any other inputs, and then see where those inputs originate, so that we can kind of make our way backwards, one step at a time, and see. So for example, since in this general area when I touch it, see I had a few of these resistors here replaced, and I'm reading nothing on them. Hard to say if they're soldered to the board or not. So there's one AND gate. We have 5 volt on the input. This is 3.3 in number 1, and this is in number 2. The in number 2 is grounded. So normally, let's say the in is not grounded, but there's 0 volt. So that means, sorry. So if the second input isn't energized, then there's probably something that is connected to that input that is loose, like a resistor, right? So, but what we're getting now is it's kind of reading low. You can hear the multimeter beeping, and if I turn the power off, it's not reading low anymore. So that means that something else is pulling this signal low. So we need to figure out what's pulling it low, which means it's not, basically what I'm trying to say is that there's nothing wrong in the circuit, like in terms of resistors or corrosion or whatever, that's affecting this pin, but something else that is indirectly connected to it that will pull this signal to the ground. So we just have to figure out what is it that it is connected to see what is it that it is that's pulling it down to the ground. So I'm gonna have to go and kind of dig around and find pretty much any board view that I can think of that would have a similar layout for this general area. And right there, so we do have this signal here, so that's a 5-volt power good. Then this one is NV and I don't even know where that's supposed to go. So let's look around. So 0 ohm jumps down to this transistor, so it's probably this transistor that's pulling it down. So let's switch over to here. So if this guy goes over here, well, we can probably test that right there. Then that means it's the it's the transistor that's pulling it down, because we're not getting a short on this transistor on this pin. So it's either the transistor isn't soldered properly or whatever. So let's go ahead and try to I'm gonna try to retouch some of these pins on that transistor, and let's see if they are just rusted. And also I will retouch the AND gate just in case, who knows. Something like that. Let's clean that up real quick. And see if we have any progress. And you see, sometimes with the the problem with rust is you just never know when you fixed it and when you didn't. So you kind of it's like the most annoying repairs ever, you know? You think you got it, and then send it back to the customer, and then you said it doesn't work. And then you try to dig around, you're not finding anything, and then whatever, for whatever reason it starts to work. So let's see. So we can test either this pin, or we can test that pin, doesn't really matter. See if that helped. So let's power on. Oh, there you go. Oh, you guys don't see it, do you? Let me turn on the meter. So there's voltage right there now. So we have voltage on this pin right there. See, 2.4 volt, and we have output, I think. No? Why do we not have output? Do we have input? Yeah, but no output. Why? What about the input number 1? So in. Oh, it's gone. Look, it's gone. See? Isn't that great? See, it's not working anymore. So whatever the problem was, it wasn't here. But applying a little bit of heat kind of fixed it to some degree. So okay, so I'm continuing on testing other U-gates, and eventually I'll show you where I started and where I came. So basically we started here because we were missing these two, and eventually I got to this diode here, and then I got to this diode, specifically to the thermal over temperature alert pin. which goes under the core. If we look at the net, it goes under the core. It goes into here on the back of the board. It also goes through the 0 ohm resistor at the front of the board between the display ports, which I checked. After which it doesn't go anywhere, which is kind of strange, but whatever. So nothing wrong here. Then on the back of the board, let me switch you to the main screen. This is the EVGA, so the board doesn't look exactly the same, except that we're gonna have to cut off this section because it doesn't exist on the board view. And we kind of land in this general area. Let's have a look. And that's kind of where it lands, I think. Yeah, I think this is where it lands, and it doesn't look anything like it because we don't have any of these components on there for whatever reason. Then we have another U gate here that we can test. Do we have an output on this U gate? Okay. Oh, the board was working, and now it's not working. Do I have an output now? Oh, so I don't have an output now, but when I pressed on the board, so nothing on the input, nothing on the other input, but when I pressed down on the board, it kind of worked. So let me cycle the switch. Yeah. Wait a minute. Oh, there we go. And the output's working. Okay. So, kind of funny. When I press here, everything starts to work. Which means the problem, the problem could be anywhere because when I'm pressing here, I am stretching this area of the board, this area here, because that's, we're stretching it, and then I'm compressing this general area of the board, which is hard to really pinpoint exactly what's being stretched, what's being compressed. But at the very least, we can rule out this section of the board by putting a couple of more standoff pins here. So what I did now, these standoff pins, they will now prevent, they will limit the effect to this area here because this part of the board is now kind of solid. So when I press on here, I'm kind of narrowing down the circle of an effect of pressure, making it more localized, if you will. So let's see if we have an output on that gate, wherever that gate was. We have an output now. Yes, we have an output. So then, let's try again. It still works. So what did we do? I hate problems like this. So, okay, let's try to push down here. Okay, so that worked. So that made the card dead. And if I let go, nothing happens. And if I push here, yeah, just trying to localize exactly what's triggering it and what part of the board. Okay, let's cycle the power. Okay, so it works now. It works. But if I bend it outward a little bit, still works. Still works. Okay. Flip that over. Still works. Push a little bit here. Still works. Push harder. Still works. Weird. It continues on working. Okay. Okay, well now it's dead. Okay. I guess I could revisit. Maybe I could reflow a few more things here and there. Probably mostly around this chip here, I would imagine. Because a lot of them are not looking very healthy. Let me show you. But you can, but hopefully you can see that this is getting annoying. I could probably reflow the controller here too. The end gate itself. Well, there could be problems here too. It's like so hard to tell. It's ridiculous. So, but I'm gonna go ahead and try to reflow as many suspects as I can, and then I'm gonna have to cool the board, heat the board, and do all sorts of things to make sure that it works in both conditions. Bend it, twist it, kick it, you know, starve it to death. Who knows? Okay, let's see if that helped. What I want to see now is I want to see it working when I'm bending it and twisting it and doing all sorts of things. So let's see. Do we get power? Okay, we get power right away. That's good. So let's push down here. Good. Let's push down here. Good. So what I'm going to do now is I'm going to put it in a freezer. I'll freeze it and then we'll power it on, see if it works. And if that does work, then I will heat it up with a hair dryer. All right. Back from the freezer. We are at 16 degrees. See? Yeah. Almost frozen. Who cares? Let's just power it on. See if we get it powered on. And we are not powering it on. See, that's exactly why I want to do that test. So if we were to push here, nothing happens. Nothing happens. Kind of makes me wonder. Nothing here. I wonder if the problem is somewhere else. It could be there, for all I know. Nothing here. Isn't that wonderful? Is it here? No. Is it here? No. Then where is it? Is it? No, it's not gonna be there. See, this is one of those things. What are we missing? Let's figure out what we're missing. So if I remember correctly, so this gate works. This gate doesn't because do we have 0 ohm on here? So both of the inputs on this AND gate are shorting. Something is shorting them down, so let's have a look. Yeah, good luck figuring out which one that is. So it's supposed to be, I think it's supposed to be down here. Okay, so yes, so NVVDD power good doesn't exist, that's correct. And then this one here, what is this? The enable RD. So we could have problem with either this resistor or this. No, that's a ground. So, oh wait a minute. 3.3 sequence. Do we have sequence 3.3? Yes. So we have that. Okay. So what are the reasons for not having? See, I don't even know if this is the chip that we're supposed to be looking at. I think so. Yeah. So this NVVDD enable, where does that go? Let's look at the net. Yeah, it's that diode again. I don't think that this AND gate exists over there. Actually, it does. So we probably have no output on that AND gate, which takes us back to that stupid diode, and then we end up cycling around into the thermal over temperature protection. So let's see. So maybe we have a problem up here. No, we don't, because we don't even have any components in this area. Okay. This is 0 ohm resistor. I think we already checked it. None of these components are in place. So yeah, 10 kilo ohm. Oh boy, that doesn't exist. Oh, what is that? What is that? I kind of wonder. Let's go over to the microscope and let's have a look. What is that one tiny resistor? I don't even know. Ah. See, wait, am I looking in the right place? Oh, okay. So here, oh, that resistor's not even there. Yeah, it's not even there. The whole circuit here is not populated. So everything here was reflown. Oh, hello. Look at that little tiny boo-hoo. Oh, what a noob. I don't even know what this is. Yeah, who cares? Let's fix that little tiny whoopsie daisy. Hopefully it's nothing.
The short is gone.
How did I miss that? I don't know. How did I miss that? Now the question is, what is this? And whether or not we had 12 volt on that pin, and where did it go? Let's look at the board view. So we had pin 2 and 3 shorted. 2 and 3. No, I don't think so. This is like a shunt. So this goes before the shunt. 12 volt in. 0 ohms, 50 ohms, whatever. Yeah. So this goes to the shunt. And then the other one would go to 750 ohms. And it would basically go to the exact same shunt, the other end. Yeah. So it's not gonna hurt anything. We got off easy this time. So what about now? Is the card actually working? No, it's still not working. Unfortunately. Kind of makes me wonder if we... Oh, yeah, see, I'm pushing it down and it starts to work. So something is here that I'm pushing down and it starts to work. And I do not know what it is. So let's see if we can push down on this chip. No, what about this chip? So if I'm pushing down on this chip, it starts to work. And I did see a little bit of corrosion on this corner here. Let me switch over to a microscope. Maybe I just need to reball this chip or resolder it completely. Let's have a look. I saw a little bit of corrosion on that pin here, the first pin, but it looks fine from what I can see here, though I'm kind of starting to think that it may not be fine at all. I mean, it looks good. I just don't know what else could go wrong. So maybe we can just go ahead and... because there's nothing on the other end. There's no rust on this end whatsoever. A little bit around the MOSFETs, but nothing concerning. So I think I'm just gonna redo this chip, and that might just do the trick. So let's go ahead and redo this chip real quick. See if we can get it to do what we want it to do. I do have some concern about the vias that go through the board. If they are rusted through, it would be difficult to figure out whether or not they actually good without probing one end and the other, which won't be fun. Because it's really hard to say. It seems to work when the board is twisted, so it works now. So press down, it doesn't work. So pressing down makes it not work anymore. So yeah, it doesn't work anymore. It worked once. If we bend it backwards, press down here. Or here. Or here. Or here. Or here. Where do you want me to press? I don't know. Okay, so that doesn't work. That doesn't work. I got no idea why it doesn't work. It only worked once. It doesn't work. So maybe something in here. Come on. Okay, so let's see if we can remove that thermal over temperature alert diode so that we can disable that circuit. Kind of wonder. Okay, so it still doesn't work, which is good. So if we were to... Oh, there's no rust here. This is ridiculous. I wonder... But I've already looked. This 0 ohm resistor here. That guy. That doesn't go anywhere for whatever reason. There's still corrosion in here that I can try to reflow. This area here is challenging because the caps are in place. Maybe we have an issue with one of the driver MOSFETs that's not communicating with that temperature alert pin. I don't know, it's hard to say. Looks like this driver MOSFET was replaced. Corrosion everywhere. Okay, so what I'm going to do now, I'm going to reflow everything in here, and we'll see if that helps. Okay, so let's see. Okay, so it seems to work now, but probably because this area is still warm, or maybe this. No, this area isn't warm. This here is warm. So if we were to cool it down a bit, I wonder what will happen. Is it still gonna work? See, it doesn't work already. Just cooled it down a little bit and it's already dead. Why is that? So my guess is the problem is not here. One last place I could look would be the actual controller itself and the circuit around it, which also looks terrible. We can probably poke around here and see if we can, but I've already reflown this, except for the controller itself. So we could try We could try poke around these resistors here, just kind of pull on them, see if any of them break off. Well, it works now, so it's kind of pointless, but if we were to break whatever is broken, see, like right now it's not powering. Right now there's no power. So maybe this resistor is bad. Nope, that's not it. What about this one? No. Maybe controller. Maybe this guy here. Nope. So something is rusty. And we need to find it, whatever it is. Maybe this pin here. We could probably go around and check with the meter. Hold on, let me show you how I'm gonna go about doing this. We could probably go just poking around, see if, let's say, does this resistor connect to here? Yes. This one, it's going to be a little bit hard because it's going into a via. Okay, see, there's connection there. Connection there. What else? There's like rust everywhere. I don't even know where to start. This looks rusty. So this one here looks a little bit suspicious. There's a little bit of rust on these pads. I could probably redo the controller too, just to make sure. Who knows? So let's redo the controller. Where is it? Right there. So let's redo the controller real quick. See if we get lucky. Alright, now let's see if that works. I don't know if you've noticed it, but there was one pad that seemed like it was oxidized or rusty. So let's flip the power. And still nothing. Amazing. If we were to push down here, nothing. Push down here, nothing. Push down here, nothing. Here, here, maybe something here, maybe something in here. I don't even know at this point. I should probably send it over to the Northridge fix. Haven't figured it out.
Magical.
It doesn't seem to matter what I'm pushing and where. It's just refusing to work. Seems to work when it's warm, so let's see if we can warm it up. Let's warm it in this area here. Still nothing. What about here? Still nothing. Okay. Still nothing. Yeah. So let's warm up here. Nothing. What about here? Oh, there we go. Boot it right up. So looks like the problem is originating in this area here. Let's cool that down real quick with some spray. So what about now? Still works. Okay. But why is that? Did something get warm up in here? Still works. Maybe the fuse? I don't think so. Because we do have 1.8 and 5. Oh, still works. Okay. Let's push here. No, let's push here. Okay, so that killed it. So once we push here, it kills it. Right? Right. And then we push here. Still doesn't work. Now I'm trying to figure out which part of the board I gotta warm up. Exactly. Not here. Not here. Not there. Not there. Not there. So it looks like it worked right about here. Which is where we have that one end gate that we were working on. So it still works. But my suspicion is that it's not the back of the board, but the front of the board. So let's cool this down real quick. Okay, so we cooled it down and it died instantly. See, right there, 0. Okay, so let's look around here. Okay, so we touched something here and it worked. Let's cool it down. It's still working. Let's push it down. Still working. Let's push it down here. Okay, now it's dead. So I think the problem is like right around here somewhere. Right around here somewhere. Very hard to say. Okay, so it works. And then if we flip it over, it doesn't. It works. So if we push here, it's dead. And then if we go here, power it on, and it works. Without even pushing anything. Okay, so what about now? What if we do it here? Nothing. What if we squeeze? Works. We let go. Still working. Still working. This is so weird, man. It almost as if it's like here. Okay, so it's dead now. Squeeze. Yeah, and it works. What else is there? What else is here? See, my biggest fear is the rusted VS. Because nothing here looks terrible. That's just the white stuff from the spray. I mean, there's really nothing here. There's literally nothing here. Except for that shunt resistor. But it doesn't look like it's rusty whatsoever. And all of the resistors I've already tested them. They all look good, yeah. Everything's looking good. I don't think the problem is here. I think the problem is at the front of the board. Like somewhere around here. I'm at a point where I just want to reflow this here maybe. It still works. So I'm just gonna go ahead and reflow pretty much everything I see here, because I don't know what else to do. Maybe these resistors here, I doubt they're needed to be reflown, but who knows. Okay, I want to remove this diode here, and I want to see if the if things will get better in terms of thermal over temperature protection. So by removing this diode, we are effectively disabling the protection from overheating driver MOSFET. Now that we have the diode out, see the diode is not there anymore. Yet this pin, we got 1.8 here, but we got nothing after. And the if we were to measure resistance on that pin, we have several K, yep, 12K, but if we power it on, see, it drops to like 300 ohms or whatever when it's not working. When it's working, it's not dropping. So let's figure this thing out. So this thing doesn't exist. There's nothing wrong with the pull-up resistor. What else? So we have one pad that goes into the GPU under the core. We have this component that I cannot find on the board. So I really don't know. I would really like to find it, but I don't know where it is. We can probably solder a wire on there. Then this is 0 ohm resistor that I think we already checked, but we can check again. This one here, I think we've already looked at. So we can, let's go ahead and double check everything again. We're gonna start with that resistor on the back, which is going to be, we're looking for a Q516. Q516. So the resistor is not there. Okay. Then we're gonna look at the 0 ohm resistor between the display ports. Is this the one? This one here. Are we reading 0 ohm? Yes. See, the resistor is working. So no problem with the resistor. Then the only thing that's left at this point would be either the pad under the GPU or this area here, which I cannot find on the board. So we're gonna have to solder a wire. We're gonna have to solder a wire here and find where that signal goes. It goes here somewhere, but there's nothing there. This is ridiculous. There are no components there. Which means it could possibly go into on this end of the board. Let's see. I'm not picking anything up. Yeah, it's not registering anything. I don't know. I can't find it. So the only thing I can think of at this point is really nothing. I can't really think of anything at this point, to be honest. So let's solder that diode back in place. I'm actually thinking about replacing some of those logic end gates, or maybe replacing the controller. I'm not even sure at this point. Something is definitely causing problems here, but I don't know what. Something's pulling that signal low. Let's see. Why is it pulling it low without the diode? Why is it going low? That transistor is not there. The 0 ohm resistor is non-existent. This is non-existent. It just doesn't make a whole lot of sense. What else? I don't know. I replaced a lot of these things here. You can see there's a lot of work had been done in this area here. Lots of resistors and coils because the HDMI port wasn't working. And there's a lot of rust. How did it even get that much rust in here? I don't know. What if the problem is not where we're looking? What if the problem is in a completely different place? Like this shunt resistor, for example, or this fuse. Let's go ahead and reflow these guys and see if it makes any change at all. No, I doubt it. But I'm desperate right now, so I don't know. I'll just do whatever. This fuse here is definitely not feeling well. Maybe we can replace it. So the shunt resistor is okay, but the fuse, I don't know. I'm a bit skeptical about the fuse here, because it had a lot of rust under it. So wonder if that fixed it or not. We have corrosion here. Lots of corrosion everywhere, so maybe I can reflow this area a little bit more just in case, just to verify. Yep, everything looks okay, I think. So there's more corrosion here. We're just gonna reflow these things here real quick, because I'm starting to think that one of the driver MOSFETs is reporting over temp incorrectly. So we can at least eliminate that. Okay, so this resistor here looks a little sick. I want to replace it. So we're gonna get to it. Oh yeah, there we go. So this resistor was bad. See right there. No contact with the pads. This one was probably okay. Though we gotta flip it over and look. Yeah, this one was okay. But this one needs to be replaced. I think we may have found it. We just need to figure out what value resistor that is. Let's see. So this would be on the back. We are looking at the board like this, and it's most likely 2.2 ohm. Okay, we can verify that by looking at other resistors. Let's verify that by looking at a resistor nearby. So, if I can find the probe, as soon as I find the probe, oh, there it is. Okay, checking for the resistor. 2.2 ohms, and the other one is a 0. So let's go ahead and replace. Let's replace this 2.2. And I'm also tempted to replace the 0 as well. So we'll do that next. I think this one's okay. I wanted to replace this guy here. Supposed to be 0 ohm. Right there. Any more suspects? This one here looks a little rough. No, I think it's okay. Really hard to say. You kind of have to flip it over to see if the pads are in a good condition. Looks like this one's fine. Yeah, I think we're fine. I don't know. Maybe that one resistor up on top was all there was. Only one way to find out. Cool it down and try. Alright, so did that help? Still no power. Like no power whatsoever, because the diode is there. And if we push here, nothing. If we push here, still nothing. If we flip over, nothing. 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 So we're getting consistently nothing. No matter what we push, right? Yeah. Okay, so I think we finally broke it completely. Which is good. Right there, see? Perfect. So it's completely dead. Which is kind of what we want to see. After all that time, it is finally dead. Or we made it worse. Kind of makes me wonder if I should go and replace every single 0 ohm resistor on here. Or at the very least we can go and check. Okay, so I think this one's toast. What is this? This one's toast, and that's going to be it's going to be 10K. So let's replace that 10K, and 0 ohm on the right is also looking kind of sketchy. Still no power. So the board's still not powering on. So let's go ahead and check. Let's finish soldering these resistors. Let's see, maybe more bad resistors that we could look at. These look good. This one here looks kind of cheesy, though it did read okay, but maybe we can flip it over and see what does it look like underneath. Let's flip this 10K here. Yeah, the 10K looks okay. This 0 ohm here, 2.2 and a 0 ohm. Yeah, this one looks fine. And this one here also looks fine. And then this one here, probably fine too. We can look under these. Yeah, I think they're okay. And this one's okay too, I think. And this one here. This one here looks okay. All right. Maybe reflow the pins on the controller. Maybe the controller got lifted a little bit with all the heat that we've been applying. This pad in particular. This pad here looks a little suspicious right there. But I think it was okay. And this pad here. Once we bypassed the diode, we were getting memory voltage, right? But we still weren't getting any voltage on the core or PECs. So let's look at the controller that's regulating the core, or operating, or however you want to think of it. And I want to look at the enable signal and see what it does. So let's switch over to this guy here and go over to the controller, pin 36, enable. So where does enable go on the front of the board? On the front of the board, the enable goes into it's going to be one of the inputs of this U gate, right? This resistor here is 10K, pull up to 1.8, and then it's one of the pins of this transistor. So let's go back and find where it is. Yeah, so let's remove this transistor. And by doing so, we will force the enable to stay high. There's our transistor marked with the K72, whatever that means. So let's get rid of it. So if that works, then we're gonna have to follow backwards in relationship to this transistor in order to find the fault. right there. That was easy. So what will happen with the resistor out? Nothing. Why is that? I don't know. Do we even have enable signal on that controller? So let's check. So the enable would be, well, that's that one pin on the right. So we don't even have enable because something else isn't working. So let's put the transistor back on there. So the chip isn't even enabled. So that was a waste of time. Let's put it back on. Kind of wonder if there was any problems with this transistor connected to the board. It didn't look like it, but who knows? Hard to say. Okay, so let's power the board. Still nothing. Okay, and then if we were to check the enable signal, there's nothing there. Nothing there. So one thing to understand about this controller is that the enable it's not an input. The enable is actually output. So let's start checking for basic things about this controller. Do we have 5 volts coming into this controller to begin with? Let's see. Let's switch over to microscope view again. There's your voltage. There's our controller. Do we have... It's funny how that 5 volt pin just looks a little like it's not done. You see that? Let me go ahead and flip the board over a little bit. Gonna look at it on an angle. Why does it look like that? So if I were to probe this pin, this pad, I would be probing the pad, but I would have no idea whether or not, I mean, if you look close, so it looks like the chip isn't soldered to the pad. So if I were to measure, the measurement would have come from the pad, not from the pin on the chip, rendering that measurement useless, right? Hopefully we can all agree to that. So to fix that, I don't know why this problem even exists at this point, because I've had this chip reflown. I'm gonna have to reflow it one more time and pay a little bit more attention to that pad. Okay, so the pad itself looks fine. We'll probably add a little bit more solder on there. It looks a little bit corroded, but nothing I would concern myself with at this point. And all the other pads look fine as well. Now let's see what happens when we flip the chip over and look at that pad. It would be this pad here, and it actually looks fine, though one of the pads, it's hard to see with all the reflections. Let me see if I can see. They look a little bit corroded, so I could do this. You can actually see the corrosion made its way all the way here. If you look closer, you can't see closer. See a little bit of that white spots around the pad? Yeah. That's corrosion that made its way all the way here somehow. So maybe the corroded pins were to blame. Or maybe the chip is corroded. Let's solder this thing on and see if that helps. So it looks a little better. I don't know if there's probably still a little bit of corrosion on the side of the chip that's preventing the solder to stick to the side of the chip. If I'm going to suspect that this chip is a problem, then I'll just replace it. But I don't think the chip is the problem. So I think we just had a bad solder joint under there. Alright, so what happens when we flip the switch? Nothing. Okay. Alright, so the last thing in my mind is rusted vias. And I just don't know where the rusted vias are. So let's take a look around. Are we gonna get a... We're not getting an image. There we go. So I don't think we have any rusted vias on the front of the board, but we may have some on the back. Still worth looking around. So it looks like it's just in this general area here somewhere, but on the other side of the board. Right there. So somewhere here is where we're working on. So we're gonna start from the top, and we can start poking around. We can start poking around these vias. Just kind of see, it's just so brittle. Just kind of poke in there and flip the switch, see if it boots the card. So that one didn't. What about this one here? Nope. What about this one here? Nope. What's that? This one looks bad here. Nope. There are any more vias here that could be suspicious, like this one here? Nope. Okay, let's go back to the controller. See if we have any rusted vias here. There's a lot more rust on this end than anywhere else. So let's try this one here. Nope. And I think a lot of rust here. Actually, I think something's missing. I don't know what this is and whether or not we should be missing it. So let's have a look. Let's see if there's any voltage on one end of that pin. And if there is, most likely we're missing it. So what's in here? Nothing. And nothing. So there's nothing on either one of these. So most likely not needed. So we can probably ignore that for now. Let's flip back over to the front and look around in the general area of the... Oh hey, we're missing 1.8. Wait, why? So we have a new symptom. Where's the meter? There's a meter. We don't have 1.8 anymore. Why? It's not short. So maybe whatever problems we've had been fixed, but the fact that we have no 1.8 volt is a bit concerning. What happened to the 1.8 volt? I want to look at the thermal camera real quick. Who knows, maybe we'll see something weird. Maybe something's getting warm. I don't see anything warming up. Okay, so the board is ice cold. Now, let's troubleshoot the 1.8. How did the 1.8 disappear? I have no idea. Going to switch to the board view to figure out what's what. There's our 1.8. So this is 12 volt in. Let's check for 12 volt in. Do we have 12 volt in? 12 volt in should be right there. We got 12 volts. Okay. Do we have VCC? Third pin from the top toward the right. Should have 5 volt. 5 volt, check. Do we have enable? Pin number 2. We have enable. Do we have where is bootstrap? SS VCC bootstrap. Pin number 4 to the right on the top. So that would be bootstrap. 4.6 volt. 4.6 volt is too low for the bootstrap to operate, which means we do not have 1.8. See, no 1.8. The bootstrap is low, which means we either have a problem with the feedback. Most likely we have a problem with the feedback. So bootstrap would go through a capacitor into the output of a 1.8 volt. Yes, after the or at the coil. This is supposed to be 0 ohm. Check. So we're not getting nothing here. Okay, so what is this? What is this resistor here? What is this resistor's value? This resistor's value is supposed to be 0 ohm. So we do make connection to the pad. Let's power it on again. Nothing there. So we have no feedback because we're not generating any voltage. Okay. We also have some resistors on the back. Feedback sense. I wanna check this whole area here. I wanna lift each resistor, and I want to see. There's a lot of rust in here. I want to see if they're good at the bottom, because they may look okay on the top, but they could be completely dead at the bottom. So let's go ahead and lift these components one by one so we can have a better look. So this one here looks okay. This one here looks good too. This one here looks okay. This one here looks okay. This resistor here looks okay. And a few more resistors here. That one looks good. That one looks good. That one looks good. And the capacitor is probably okay. I must say this capacitor here does look a little rough. Maybe we can... I don't know if I should replace it or not. Depends on the type of a capacitor. If it's a filtering capacitor, it probably doesn't matter. Not a lot anyway. The shunt resistor is probably okay. Yeah. And the fuse is very sketchy. But it looks okay. Okay, so feedback looks okay. I didn't see anything major there. Though I didn't check the values. But everything was working before, so I don't know. Maybe the chip had died. GS9216. So I'm going to go ahead and replace this chip. So the chip I'm going to be putting on now is a little different. It's a UP9628P. I kind of wonder, in theory, this is a good replacement. I don't know. We're going to find out soon enough. Alright, so let's see. Are we gonna get a winner today or not? I've already checked the resistances on all of the pins, except for the rail itself. 1.2K. Okay, so I think we're good. Now let's power on. Still nothing. Why is that? Oh. Forgot this. See, that's what you get when you get old. Okay, one more time. Are we gonna get 1.8? Bingo.
Magical.
Holy cow. The card is pulling 3, almost 3 amps. I want to see what's going on. I don't want to keep it powered for too long. I need to get the thermal camera so I can see what's going on. Hopefully none of the DR MOSFETs are crazy because of all those resistors that we moved around. Ooh, one actually does go crazy. See? I think it's the one that I replaced earlier. Why? What's wrong with it? What is wrong with this thing? No idea. Let's have a look. Let's have a closer look. Maybe something was desoldered, or maybe it just died. I'm very tempted to go look behind the board to see if maybe we screwed something up. I don't think so. Everything's looking good. Let me double check these resistors here. So these are supposed to be 0 and 2.2. Correct. 0. 2.2, and this one was like a 10K or something. 0, 0. So this one's a 10K, isn't that right? Yeah, it's reading 9, but I'm guessing it's 10. This one's reading 9 as well. Okay, so my guess is that kind of wonder what resistance is on 12 volt now. Oh, it's not low. What about 5? 5 is okay also. And the 1.8 is still good. Why did this driver MOSFET went bad all of a sudden? I don't know. So let's go ahead and remove this. Put in a new one. This is a BLNO. So my only concern now is I really hope that the problem is this DRMOS and not the one next to it. There we go. Out with the old. In with the new. Let's power it on. Let's cycle the power real quick and see if that driver MOSFET flashes. If it flashes, then most likely something's off with the feedback circuit. Yep, it flashed. I don't know if you can see it. See it right there. It flashed, which means it's not the driver MOSFET that failed, but something else. The good thing is that we're making progress. That's all that matters right now. Whether that progress is in the wrong direction, it's still a progress. So let's get rid of the 10K first. It actually doesn't look bad. I'm gonna measure this. And I'm gonna check these 0 ohms here. Just gonna move them first. Check them. Yeah, the pads under them look fine. I think the resistors themselves are fine too. I don't know. Yeah. Yeah, that resistor looks fine. Yeah, there's no rust. There's really no need to change anything here. Everything's looking great. I don't think I have to worry about anything in this area here. If anything, it would be right next to the controller itself, where probably one of the resistors around the feedback have gone bad, because there's a lot of bad resistors there for sure. All of these look good to me, so I'm just gonna leave them alone. You will see that all of these resistors here are in a terrible condition. Like, I don't even know. And I really wonder which one is it that I'm looking for. I guess I'm just gonna have to open them all up, lift them all up, and kind of see one by one, and hopefully we can spot one that's not good, because I don't really know which of these resistors is bad. If any. So we might as well lift them all one by one. Which really sucks, but just doesn't seem to be another way around this. So we're gonna start from here. I mean, they all look bad, but just how bad, who knows. This one looks okay. This one looks okay. See, the sad part is that it may not even be feedback. It may just be the adjacent driver MOSFET. You just never know, because they are connected with the ZDC pin. So who knows? See, it's still doing it. No? Yeah, it just goes into protection mode or whatever. So it may be that let's see. Try to figure that out. So second pin, let's go to the bottom. See, so the second pin, 0 ohm to ground, no. 10K. 10K to this resistor here, which is another 10K. We don't have that. Let's see. 10K. Where else do you go? 2.2 ohm. VCC. I don't know. It doesn't look like it's connected. So we can probably just start looking at these and compare them side by side. Because right now this is balls. So let's see if we can gather anything out of here. So I checked all these resistors and they all look the same. The caps, I don't think so. Let's swap the DRMOS. See what it does. Actually, no, let's not swap. Let's take the old one, since we know it was behaving the exact same way, and put it where the bottom one is and see if that helps. All right, let's try again. Let's see what it's gonna do now. I'm thinking we have a bad controller and it's not one of them DRMOSs. Yep, doing the exact same thing. See it right there. And the card is shutting down due to the over temperature protection. Let's go ahead and swap that controller out, see if we get lucky today. Oh boy, I'm getting old. I think I soldered the wrong controller here. Yep. Oh no, it's actually right, yeah. I thought this said, it said P. Is this P or R? I think it's R. It's gotta be R. Yeah, it is R. Okay, never mind. Thought I was losing my mind. Or maybe it's P. This is R. I think this is P. Oh my god. That would explain the problem. Or maybe it is R. I don't know. It does look like a P to me, so I don't know. It's like, it's not very well defined R, is what I'm trying to say. Whereas this one is. Who knows? Maybe another one of them fake chips from China. Okay, is it gonna work now? I don't know. Why is this card failing? It's just failing everywhere. Okay, so let's check for short on 5. 5 looks good. Yep. 1.8 doesn't really matter. 12. 12 is good. Okay. What are we gonna get now? Same thing. It kicks in and it kicks out right away. And it's the exact same driver MOSFET. Yep. Why? Well, we do know that it does pulse. I'm still thinking feedback circuit. Let's measure this resistors and see what kind of values we get. Because I am dying to know what's going on. We're going to start with ISEN 1. Or no. What is this rail of resistors? So 3. I mean, we can check them all. So this one here, 0, must be 3.3 or whatever. So 0, 0, 0, 0, 0, 0, 0. Okay, so let's first remove. Well, this one looks good. This one doesn't. So let's first remove 0, 0. This one looks good, but this one here looks bad. But it's working, so I don't know. Okay, so I mean, we can probably jump around the pads and kind of test. So we have connection there. Then from here to there, we have connection there. Yes. Okay. Good. 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 So you can see I'm not testing them at the base. I'm testing them to the top of the component. and then into the trace. So that way I know it's actually connected. So this here probably goes somewhere. See, right there. So we're good there. Good there. Well, I think everything is fine in here. What about this guy here? Yeah. Yep. Don't know where that go. If you go in here. I don't know where that go. Okay. What else could be a suspect? Maybe the values of these resistors went bad. Let's go ahead and swap all these resistors here and see if that will change anything. Because if it does, then we'll know exactly what to do. Okay, so that didn't help. The exact same driver MOSFET is acting up, so what I'm going to do is I'm going to replace the one that's above. And if that doesn't help, then I don't know. Then I don't know. I don't know what's wrong with this card. Okay, I don't even know what I've done now. I think I swapped the driver MOSFETs around. Why I do that? Probably because it's 2 o'clock in the morning and I don't know what else to do. Because right now I can't even think straight. So let's check. 12 volt. Nothing. Nothing in 5. Let's see if we power it on and see what happens. Same thing. It gives me one little burst and it shut itself down. One more time, I think the problem starts with the one at the bottom rather than at the top. It just kind of shifts over to the second one, but it actually starts at the bottom, somewhere around here. See that? That's this resistor that I believe supplies 12 volt to that driver MOSFET. Yes. And so it may be the first one that's going bad. Over here somewhere. I don't know. So maybe we can look at the first one, but I don't see anything. It happens so quick I can't even see anything. Maybe we can cool it down. And see if we can get a better picture. I don't see anything. What are the chances of coil gone bad? Not the coil, but the capacitor. After the what are the chances? Who knows? We may even have problems with these capacitors here, so let's get rid of this capacitor. Not sure which one I want to get rid of. Kind of hard to say based on this view. Probably this one. So this capacitor could possibly be bad. So let's get rid of it. But I don't even think that's a problem, though it could be, but I doubt that. I think the problem is somewhere else. So the capacitor is gone. Anything change? Nope, nothing changed. Though I do get a flicker, suspecting that capacitor here. Maybe I can get rid of it and see if that helps. Let's see. Okay, so the capacitor is out. Let's see if anything changes. Nope, nothing changes. So I soldered the wire to the PVM of that driver MOSFET, and I found out that this was actually phase number 5. So I started poking around phase number 5 ISEN, and I stumbled on a capacitor that was basically soldered only halfway to the board. So this is a 100 nanofarad capacitor. So let's go ahead, solder another one in there, and see if we finally get this thing to work. One little capacitor, so much trouble. Okay. Hopefully this is it, because I have no more patience. It's 3 o'clock in the morning. I need to go to sleep. One last try. At the very least, we narrowed it down to that, to the phase number 5. So if anything, I will look at the rest of the components tomorrow. So right now I want to see good power, and I don't want to see anything getting hot. So let me get rid of that PWM wire since we don't need it anymore. We're not getting anything on the core, I think. I don't know. Yeah, so the core is not doing anything right now. I can imagine. Not sure why that is. Let me see if I still have 1.8. So we still have 1.8. But once we replaced that capacitor, nothing seems to work. Don't know why that is. Maybe I messed up that PWM pin. Let's go ahead and retouch that. I doubt that's gonna make a difference, but never know. Yep, no difference. So now we need to figure out what's wrong with the power good. Let's go ahead and remove this transistor like as before. Hopefully we can force the enable to stay high. Okay, so that did it. So if we look at the thermal camera now, let's see if any of the phases are showing any excessive heat. I don't think so. And I think we have all of the signals on all of the driver MOSFETs. This circuit is now powered, most likely due to the over temperature protection circuit is also corroded, and I could probably finish up figuring out which resistor is responsible for that. Because they're all connected in parallel, I would have to go and look at the entire circuit for the temperature monitoring pin. Yes, I don't know. So in this instance, it's this resistor here, this resistor there, this resistor there, and then in here it's probably this guy. Probably. And then here, I don't know if this resistor is any good. Let's go ahead and check it. It's supposed to be 0 ohm. So let's test this. Okay, so we're connected there and here. Okay. And that's basically how we can check every single one of them. So we know it's going to be this one. Then we can see if we're making connection here and there. Okay, so we're good there. We're measuring top of the resistor basically, in case if it doesn't connect to the So I think TMON circuit is good. Good morning everyone. So what I did was I soldered a wire to the back of the board on the TMON pin on one of the resistors, and I checked that they're all in fact connected. Right, all the way there. So it kind of makes me wonder why only 3 of the driver MOSFETs were showing any kind of activity for whatever reason. So let's go ahead and inject 1 volt in there and have a look one more time. Yeah, you can see that there are 2 driver MOSFETs in particular that are doing that. Almost as if none of the other 2 even care. So it will be these 2 here, one of which was replaced a while ago. Now the resistance on that signal is actually 10 ohms, so it's very low, so it's not supposed to be 10 ohms. Now why that pin is shorted, I don't know. We're gonna have to see if I can replace those 2 driver MOSFETs and see if that helps. Okay, so let's see which one of these 2, probably both of these dear MOSFETs had a short thermal pin. It would be pin number 2. Yep. So this one is short. And this one is also short. Let's compare that to another driver MOSFET that's possibly dead, and that pin is not short. I think something else is still short. Maybe another driver MOSFET. Let's have a look. I don't see any of the driver MOSFETs glowing when I press the button. So maybe everything is looking good. So nothing blown up. I think we have all of the power stages active. So good signal, good, 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 and good. So all the lines, all of the signals are looking very good. I'll go ahead and put that transistor back onto where it belongs. And so that we can try powering the board without forcing the enable signal high. Got a bit of flux on there, because forcing anything into anything isn't good. Sometimes it's good. Like if you're a parent and you want to force your children to do something that you know is right, that's one thing, you know, because they don't understand what's good, what's evil, what's right, what's wrong. They're kids. So, but otherwise it's not a good practice. Nope, it's just one little flash. And that's it. So my guess is the enable signal gets pulled low. Why does it do that? There's a million reasons for that. So we're basically going back to this diode. And then basically we're gonna go back down into this diode here, which is our prevention for over temperature alert thing, whatever. Where are we? Oh, we're at the front of the board. Okay. Yeah, so eventually we're gonna get into here, into that very same place where we've been before. So we have a short here. So this dual NPN transistor here, or so I think, this guy here died. Alright, so transistor replaced. No more short. Okay. It looks like it stays powered. Let's check for PECs, see if we have PECs. We don't have PECs. Why do we not have PECs? Do we have memory? Oh, we don't have memory. And we don't have anything else anymore. So whatever happened, it ran for a few seconds. And now it's not running anymore. And that pin is now short again. So let's check if any of the pins on that transistor are shorted. So, do we still have a short here? No. What about the transistor? So this is probably ground. So these two are parallel. This one and this one, so we're good there. So I don't know, this transistor, I replaced it 3 times, it keeps blowing. Something keeps killing it for whatever reason, I'm not sure. And nothing really seems to be blowing, glowing on the board. It just goes bam, and it's dead. So we got 5 volts, 4.6, 4 volt here, 4.8, 4.8. I don't know if this is normal. Makes me wonder what would happen if we just kind of ignore this whole thermal fault circuit and just get rid of that transistor there and just kind of go along without it. And so let's put that transistor into here instead. Hopefully it will stay there and not blow. Let's see what kind of voltage we get. So we have memory. I want to see what kind of voltage we get on this transistor. So there's 0 here, 0 there, 3.7 here, 0 there, and 4.4 there. So 3.7, 4.4, and then we have zeros in here. And I think that's the way it's supposed to work. And we do have memory, and we don't have PECs. So we still don't have PECs. And we're still reading 50 ohms on that thermal protection thing. For whatever reason, I don't know. It might be, maybe another driver MOSFET out there is half dead, but all the signals look good. So let's figure it out. Let's put the heatsink onto the board, turn it on, and see how long it would last. I don't see anything overheating anywhere, so everything's looking good. Yep, everything is looking good, and but we're still missing PECs for whatever reason. So let's figure out what the deal is with the PECs. We can probably ignore the thermal problem for now. So this is our PECs right here. Let's see what is it that we need to test. So we need 12 volt coming in from here. Do we have 12 volt? Yes. Then we need 12 volt on this pin. Yes. Do we have enable? Pin number 2. Pin number 2 is gonna be right there. 1.6 enable present. Do we have VCC? Third pin down from the right. 1, 2, 3. Should be in here. 5 volt VCC. Do we have bootstrap? It's going to be a second 1, 2, 3, 4th, 5th pin down. This resistor here. Bootstrap is 4.5, so the controller is not properly functioning. Do we have any rust on the back? Most likely we have a ton of rust on the back of that controller. Likely to be an issue with the feedback. Right there. There's plenty of rusted components. Okay, so I think we got a problem with this resistor here. Let's go ahead and figure out what that resistor is. Okay. Let's see if that works. Corrosion is a nasty, nasty thing to work with. So do we have a connection from here to there? Yes. I think we're okay. I still don't like this resistor here, but it looks like it's working, so. Yep, there we go. Hallelujah. We got PECs. HDMI cable and a heatsink. So everything's connected. 1, 2, 3. Forgot the power cable for the power supply. It's like the second most important thing. Okay, there we go. Take 2. All right. Are we gonna get a picture? We had few beeps. Nothing's on the display. Okay. Let's go into the memory test and see if we are detecting the card at all. We have Samsung. So let's see. Do we even have a detection? Yes, we do have a detection. So then we're gonna run mods. Let's run mods. See if we have a problem with the memory here somewhere. No, we do not. Okay. So let's run mats. I think the mats is gonna run. See, we got a pass. So let's close this. Shut down. Probably. I don't know. Why do we not get a picture? Maybe we have a dirty PCI Express slot. I don't think so, because this is a brand new riser. Everything is good here. Connector, power cables. I think everything is connected. Let's try first HDMI display port. See if we get a picture from that. Yep, I think we got a picture from that. Just a second. There we go. Okay, so the card does produce a picture, but we're not getting a picture from the HDMI port. Why is that? I don't know. Let's try again. Switch into HDMI. Oh, there it is. Never mind. We're good. Probably dirt or something, or port connection somewhere. We got a working GPU. Now I know some of you professionals out there are probably gonna give me a hate comment, being unable to resolve the problem with the thermal overtemp protection circuit, and I get it, but I don't know. I think just like with the two driver MOSFETs that I have replaced here earlier that were shorting the signal down for whatever reason, it didn't seem to matter, because the everything was working in terms of the power delivery and everything, but for whatever reason there was a internal fault inside of the driver MOSFET that didn't prevent it from working. It was just reporting false positive, and I think we still have one of the driver MOSFETs reporting false positive somewhere. Though what I can do, here's what I'm going to do. I'm going to disconnect 0 ohm resistor from that circuit, one resistor at a time, and then I'm going to measure for resistance on that pin. And then, because right now we're getting 50 ohms. See? So if I were to remove this, then I want to see which of the driver MOSFETs is creating that problem. So this is the end of the rest of them, and then here, see, nothing. Like mega ohms, right? Good. So this is not the resistor. This is not the driver MOSFET. It's not the first one. Is it the second one? Nope, it's not the second one. Is it the third one? It is not the third one. Is it the fourth one? Or the fifth one? I don't know. Let's find out. So one at a time. Nope. What about this one? Is it the right one? Yes, that's the right one. Nope, that's not it. What about this one? That's it. Well, I think we found it. I think we found it. See, because we're not getting 50 ohms anymore on this pin. We're getting it on here. So that means it's going to be 1, 2, 3, 4, 5, 6. So it's a DRMOS number 6. So, which is going to be 1, 2, 3, 4, 5, 6, which is going to be this guy here. If we measure that pin, it's supposed to be this pin here. Right there. That's the son of a gun. So let's go ahead and replace it and see if a resistance is normalized. Okay, so I salvaged a few more of these dual NPN transistors from another board, and I want to solder it on. See if it'll power. When it's soldered to the board. And hopefully that transistor here will not blow once again as before. So let's go ahead and put that thing onto the board. Right there. And I'm gonna have to give this card a sonic bath. There's flux everywhere. After so much work, it's ridiculous. So if this doesn't work, I'm just gonna ignore it. The moment of truth is oh, I broke my screen again. Anyway, who cares? So let's power the thing and see if we get PECs. So do we get PECs? Nope, we do not get PECs. It is still pulling low for whatever reason. So I'm just gonna have to ditch that transistor and call it quits. Go give this card a bath. We're gonna make sure that we do not have a short on that transistor on the right. Okay, so I think we're still good. So we didn't kill anything. And I'm gonna go give this thing a bath. Put it together and run stress tests to make sure that everything works as it should, despite them missing over temperature circuit for whatever reason. I don't know why it's not working. What kind of resistance are we getting on it anyway? Assuming we fixed it. Like several mega ohms. Okay. I don't know. Who cares? Let's give this thing a bath and we'll get back with the testing. I think that's it. It worked fine. No issues were detected. So we're gonna put it back together. Test it one more time just to be sure, and send it back. And that's what the rust repairs look like sometimes. I absolutely hate rust repairs, especially on this scale. A lot of time, well, not a lot, but sometimes it's just one general area. But in this case, it was like everywhere. I don't even know how they got it this wet. How was it wet from... It was wet around here, there, and then the front of the board. I don't even know where has this GPU had been and how it got so rusted. And the bottom line is, if it breaks again, I'll have the customer ship it over to me again for evaluation, and if it happened to be dead, I'll just give him a refund. Screw it. I don't want to deal with this thing anymore. So much rust. It's so unpredictable. The amount of damage is just beyond imagination. So 3 days. So first time when I got it, I probably spent at least a day trying to get it worked. And then it worked. I think he said like it worked for like 10 days or something. And then it quit. So then I spent 2 more days working on it. Finally got it fixed. And no pay. It's a warranty repair. And if you feel like I should have gotten paid some kind of money, be my guest. The donation link is at the bottom of in the description section. You can, yeah, feel free. Send me a little bit of money if you want, so I won't feel too bad. But whatever, you know, I won't feel too bad either way because we've got a video out there, something for you to watch. Not exactly a video; it's more like a movie, because it's very long. From which I hope you learned something. Maybe you learned that don't send me GPUs that had so much rust. Though it would be the telltale would be these screws. I mean, look how much rust is on the screws themselves. So if you see this, then it's a whole lot worse. It's a whole lot worse underneath. So thanks for watching. Have a blessed day. Goodbye.